Today we are going to be learning about explicit formulas for sequences. The big idea of this lesson is that sequences can be thought of as functions, but they have their own notation different from other functions. In their terms, if their terms are real numbers, they are real functions and can be graphed. So, it's very simple. We're just talking about something slightly different than functions. So, a sequence is just an ordered list of numbers or objects. The book defines it as a function whose domain is the set of all positive integers, or the set of positive integers from A to B, which is basically just this. I don't know. So each item in a sequence is a term of the sequence. And in this first activity, we have a sequence here. And it is a sequence of triangular numbers. So it's just saying that if we call this t, then t sub 1 would be equal to 1, t sub 2 equals 3, t sub 3 equals 6, and so on and so forth. And an easier way to write it than putting in parentheses would be a subscript, which is also called an index. So then, with this same logic, what is t4 and what is t5? T sub 5. Well, we're going to be following the same pattern that we have been. So, if we have 1, 2, basically just going to keep making a triangle. And when we get to 4, we're going to have 10 dots. And when we get to 5, we're going to have 15 dots. Now that was a bit tedious. And the book teaches us that it does not have to be that tedious. Gives us this function right here. So you can just generalize the idea to have a formula for t sub n. So this is good because you can just make a rectangle and you can just get anything. So, suppose you flip a coin until it comes up tails. So we're gonna, probability that you will not have the outcomes and comes the sequence. So right here is our formula. Then down here we're going to have p sub 1, p sub 2, p sub 3, p sub 4, and then we have p sub 20, which is going to give us this probability. You could have figured this out just by using what you have before. But this makes it much easier, right? Right. So we're going to learn now how to use explicit formulas for sequences. And we're going to look at one from finance, this example. So it is common for people to save money in saving accounts. Here the book gives you a bit of background. But what we really need to know is that what this does is they're going to give us a function right here. And that is going to be our explicit formula. And a sequence is an example of a discrete function, which is just a function whose domain can be put into one-to-one correspondence with finite or infinite set of integers, gaps or intervals between successive values in the domain. The graphs of a discrete function consist of unconnected points. So, as you can see here, unconnected points.